Hi guys. Right, today I'd like to carry on our theme of errors, and we're going to look at the size and power of a test. Now it says you need to be able to calculate the size and power of a test. You have already seen that a type 1 occurs when the null hypothesis is rejected when it is in fact true. The probability of a type 1 error is written as alpha, and it's often known as the size of the test. The size of a test is the probability of rejecting the null hypothesis when it is in fact true, and this is equal to the probability of a type 1 error. The size of a test, as you have seen, is the actual significance level of the test, and this is usually chosen before the test is carried out. When conducting a hypothesis test, you should be interested in the probability of rejecting the null hypothesis when it is in fact untrue, as this is clearly a desirable feature of the test. The probability of rejecting the null hypothesis when it is untrue is known as the power of the test. Quite a fitting word, because that tells you about how good your test is. So it goes on to say the power of a test is the probability of rejecting the null hypothesis when it is not true. So the power is 1 take away the probability of a type 2 error, or for example, and that means the probability of being in the critical region when H0 is indeed false. So the greater the power of a test, the greater the probability of rejecting H0 when H0 is false. It follows that the higher the power, the better the test. And the table that we've written before can go on to be changed to give us this. And you'll notice that the size and the power both relate to rejecting H0. The size relates to when H0 is true and a type 1 error has been made. The power relates to H0 being false and a correct decision was made. If the power is greater than 0.5, the probability of coming to the correct conclusion, i.e. rejecting H0 when H0 is false, is greater than the probability of coming to the wrong conclusion, i.e. accepting H0 when H0 is false. So you've been told before, if you increase the sample size, the probability of a type 2 error decreases. It follows that the larger the sample size, the greater the power of the test. Increasing the sample size is preferable to increasing the significance level as a way of increasing the power of a test. As always, you get better results if you increase the sample size. So I'm going to go on to look at this question. It says a random variable x has a binomial distribution. A random sample of 25 was taken to test the H0 of the probability being 0.3 against the H1 of the probability being less than 0.3 using a 10% level of significance. And we're going to start by finding the critical region for this test. Okay, so we know that x is a binomial, and we're going to look at 25 in the sample, and it's got a probability of p, and our H0 is that p is 0.3 and our H1 is that p is less than 0.3. So what we're looking at is a one-tailed test. So what we're looking for is, because it's less than, we're looking for this bit in here. If I were to think about it as a normal curve, and I'm looking for this critical value here, so my probability of x is less than or equal to c is less than or equal to 0.1. If I look at my tables, I can see that the probability that x is less than or equal to 4 is 0.0905. So C is 0.0905. and so that's the critical region. Okay, so that's a start. Now part B asks for the size of the test. Now that is the actual significance. And because this is a discrete distribution, you'll know that it's not going to be exactly the same as what it was here. Remember before, a continuous distribution gave exactly the same as the significance level. So this one, size to actual significance is 0.0905. That's really nice and easy. Right, so the next part of the question says, given that P equals 0.20, calculate the power. So we're looking for the probability. For a start, we're going to look at the probability of type. So the probability that we are going to reject it, so it's in the critical region, and we're looking at a binomial with the value of the probability is 0.2. And if I look at my tables, that comes to 0.4207. So that is the power of the test. So this is the size, actual significance is size, and the probability that still in the critical region given the actual probability is the power. Okay, so coming back to this table here, we've got the size in here and the power in here. It's important to know they're both to do with when H0 is rejected. So here H0 is true but is rejected. That would be the size, so that we want that to be as small as possible. And H0 is false is the power. We want that to be as big as possible because we want it to be rejected if it's false. We want it to be rejected if it's false. We want it to not be rejected if it's true. So the size needs to be small, the power needs to be big. I don't actually think 0.4207 is that good for that test. So that's an interesting point to make. Okay, thank you.